Alright, hello, welcome back to A Software Engineer Plays. We're back in my favorite spreadsheet application, Microsoft Excel. I know a lot of you are probably thinking, wait a second, this isn't video gaming, this isn't educational. Well, it's not video gaming, but it should be educational. Today I want to start working on what we talked about last video, which is writing tic-tac-toe in Visual Basic for applications in Excel. And kind of go over a lot of the programming concepts and really try and get a little bit more educational about programming. So, without further ado, let's jump right in. If you remember last time, we did set up our Excel to be developer enabled by right-clicking in the ribbon and customizing and making sure we checked developer there. We open up our Visual Basic window here. And we're going to start a brand new project. So let's get ourselves all set up here. Here we are, side by side. And the first thing we want to do is we'll start with a two-player game. So first of all, we want to define our game board. So tic-tac-toe is obviously a 3x3 grid, but the way we want to do it is, let's see, we'll have, use what little art skills I have to make a beautiful tic-tac-toe board, and we're gonna make it square as possible here. Make everything 16. Ooh, okay, that's really small. 50 pixels by 50 pixels. Okay. It's not quite square, is it? I have to do every one at the same time. There we go. Okay. So we've got a game board. I kind of want it to be offset a little bit here. And I want these to be a little bit smaller. All of this aesthetic stuff that doesn't really matter. There we go. So we'll put X's and O's in our board. And we'll give it a nice, calming green border. Nice. Okay. So, we've got our game board, we've got our code window, so let's start writing some code. So first of all, public sub, we want to initialize everything that we might need. So we'll call it init. And there we go. Okay, so we've got our subroutine defined. So let's just think about the problem first. What are we going to need to keep track of? Well, first of all, obviously, we're going to need to keep track of the current player. We're going to need to keep track of the board. We're going to need to keep track of whether the game is over or not. And, well, that sounds like a pretty good starting point from here. So let's go ahead and declare our variables. So we talked a little bit, we kind of glossed over variables last time, but variables are basically containers for certain types of data that can change their value. Their value can be variable, hence the name. And we have a bunch of different types of variables that can be defined. So, for example, if you wanted to declare a number, you can declare that number many different ways. So you can declare an integer, you can declare a single precision floating point number, a double precision, there are a bunch of different types, and all those types define how many, if any decimal places, how many decimal places, and how many bits in memory the variable itself will take up. You also have variable types like character, which is a single letter. You have string, which is a string of characters or words, in this case, like game over. And then you can get into a lot more complicated custom object types, which you can also declare as variables, but we'll talk about objects and classes later on in the series. You don't need to worry about them right now. So let's start off by declaring our variables. So when you're writing code like this, if you want to have variables that are accessible by every subroutine in the file, it's a good idea, it's good practice to declare them as private. And what that means is that only the subroutines and functions within this module, the tic-tac-toe module, will be able to access the value of this variable. And why that's a good thing to do is because you don't want necessarily other modules to change the value unexpectedly. We call it encapsulation in object-oriented programming, which basically you want to bundle all of the data for this module within this module and hide the values that other modules don't need to see, just because it's safest to do it. So that's the private keyword here, means that only functions and subroutines within the tic-tac-toe module will be able to see the value. So we'll call this player, and now to declare it as a string, because we want to use the name, private player, we'd say as string. So this variable here will hold, you know what, I'm realizing now we probably want to have different variables for the two different players, because we're going to do a two-player first. So we'll have player 1 and player 2. Then let's we'll declare an integer to keep track of who the current player is, if it's player 1 or player 2. And then let's see, the board. So we haven't really talked about arrays yet, but an array is essentially a list. You can think of it as a list. And it is essentially a list, either one-dimensional, a list of X many values, or you can make it two-dimensional, where it would be a table of sorts. So we want to make our grid an array, and to do that we're going to declare it here, private board as let's go ahead and store integers in the board for now, but to declare it as an array we're going to do it here, and the keywords are the to. And basically what you're telling VBA here is the starting index of the array, which in this case I'm going to make 1. We're going to go 1 to 3, and then because we want it to be a 2D array, because this board here is 3 by 3, we're going to declare the second and I'm putting it in the wrong place here, so it needs to go over here. There we go. So board 1 to 3, comma 1 to 3. That means it is a two-dimensional, because there are two items here. Two-dimensional array. Each dimension is 3 large. Now, somewhat unique to Visual Basic is arrays. You can choose how they are indexed. In a lot of programming languages, a lot of the C, C++, C#, etc. languages, arrays are always what we call zero indexed, which means that the first index in the array is always the 0th index. So we can emulate that in VBA. If I made these 0 to 2 and 0 to 2, then you would have a 0 indexed array, but one indexed from 1 kind of makes a little bit more sense to humans, especially humans that haven't been writing code for many years. So we'll go ahead and start with the 1 indexed array. But when you get to C based languages, 0 indexed arrays can actually be very useful, and there are a lot of nice constructs that deal with starting from 0, but we'll worry about that later. Alright, so let's go ahead and also set a variable called game over, and what we want to do this is use a variable type called a boolean, and a boolean is a special kind of variable that has one of 2 values. It can either be true or false. So 1 for true, 0 for false. Just a really easy, quick way, and very lean. It only uses 1 bit of memory, 1 or 0, to determine whether something is in a given state. And because we're going to need it, let's go ahead and also declare a winner. Actually, let's declare that as the integer, because we already have the names. We don't need to use a string to declare the name again. We'll just use the integer to refer to player 1 or player 2. Okay, so let's go ahead and initialize some of these variables in our init function. So first of all, we want to, like we learned in the last video, set player 1 equal to user input. So we're going to use an input box here. What is player 1's name, comma, player 1 name entry, and that's good. I'm going to copy and paste this for player 2 because I'm lazy, and because no one wants to listen to my keyboard that much. Alright, we'll go ahead and say that player 1 always starts. We could theoretically come back and build some randomness into this. Okay, and we'll also say that player 1 for now will always be X's, and player 2 will always be O's. Current player is 1. Oh, another thing to note, the single quote that I'm doing here, if it's at the beginning of a line, that makes it a comment. So the compiler doesn't read this, it's just a note to me, it's a note to you to tell you what's going on in the code. It's always a good idea to write comments in your code so that people know what's going on without having to actually parse the entire line of code and think like a computer. Anyway, moving on. Current player, we've done. Let's go ahead and set the board up. Now, because the board is a 5x5 array, we're going to have to write some slightly custom logic here to get the board. If it was 3x3, it would be very easy to get the board because I would be able to say board equals, like we did last time, this workbook.worksheets tic-tac-toe .range b2 to f6. That would be super easy. If I get the value of those, I would automatically get the value of all of these cells into a 2D array. However, because I'm choosing to show the nice lines here for the sake of aesthetics, we need to make it a little bit more complicated, and that's okay. What we're going to do is we're going to say with this workbook, worksheets tic-tac-toe. Okay, so now we're referencing this sheet. We can start saying board at 1, 1 equals... Actually, this is kind of fun. We don't actually need to do this step right now because VBA will automatically instantiate the board with a bunch of zeros in it when we start. So just to prove that to you, I'm going to come... I'm going to comment out this block of code. This button here, if you've added the edit options here, will comment out a block of code, which is very useful. So if I step through pressing F8 inside the init subroutine here, you'll see if I drop down this little plus button here, you'll see all of the variables, private variables that are part of the tic-tac-toe module. If I drop down the board, you'll see this is the first layer, the first dimension, and then the second dimension. Everything's got zeros in it already. Now, because we haven't started playing yet, we don't need anything in there except for zeros, so we don't need to do all of this board initialization. So that's good. The winner's already been set up as 0 as well. So, player 2's name will be one of my cats. And it all just went away there because there's nothing else to do. You'll see what I did there. If you click in this gray spot, gray line, you'll see it puts a red circle, and that's called a breakpoint. This is very useful for debugging. If you want to stop the code at a certain point in its execution, you can put a breakpoint, and then the compiler will break when it gets to that line, or the interpreter, or whatever is actually executing the code. So in this case, I want it to end on the end subline. So now you see it's the yellow arrow is here to say that it's about to execute the end subline, but we can go in and see, okay, player 1's a software engineer, player 2's Moss, game over is false, current player is 1, everything that we've set up. And now if we hit F8 or F5, it will continue executing, which means it'll just end. Okay, so we're done. So we've got our init function, and now let's work on actually playing. So first of all, we need to have a game handler subroutine. So this is going to basically start off by calling init, and then basically, the way tic-tac-toe works, and every other game essentially works, is you continue to do something while the game is not over. And while there is a keyword for a structure that we call a loop. And looping is very important in computer science, in writing code, because it lets you reuse code efficiently, and you can do the same block of code X many times and update variables in those loops time and time again until a certain condition is met. So there are a couple of loops to talk about. There's the while loop, there's the do while loop, and there's the for loop. And they all essentially do the same thing, just slightly differently. Basically what they will do is repeat blocks of code until a certain condition is met. So the while loop, basically you say the condition. So in this case, the condition we want to check to see if it is complete is game over. So while the game is not over, so while not game over, w end is the while loop end keyword here. Basically, this will print hello infinitely many times because game over will never set to true. And I will show you that happening here. I'm going to put a breakpoint there. We're just going to do that. Okay, so hello, and we'll check the value. Game over is false. So it will print forever. And what we've done here is created an infinite loop, which is not good in the world of programming. So you always want to make sure that your end condition does actually get met at some point. Because if I didn't have this breakpoint here, the whole program would lock up. And I'll show you that. I'm gonna save everything so that we can get back to it. But we're gonna run this now. And now you'll see it's printing hello ad nauseum, and I cannot. Excel stopped responding. the VBA window stopped responding, and the reason for that is the computer is devoting all of its resources to printing out hello in the immediate window. There are a couple ways you can try to get out of this without crashing down Excel through the task manager. If you hold down escape, you might get lucky, and it might pop up a message to say execution halted. But in most cases, and this is why I saved beforehand, you gotta restart the old program. And we're back. So yes, always a good idea to make sure that your end condition is set when you're dealing with loops. So a slight variant of the while loop is called the do while loop. And what the do while loop does, this is the syntax for it. Get really frustrated with the VBA compiler sometimes. Basically, the do while loop is like the while loop. However, it will always execute at least once. So let's debug print hello. Debug while not game over. Okay, so this will show it really well actually, because the previous loop is going to set game over to true on its first iteration. And then you'll get to see it enter the do while loop. So we'll do the initialization, A and B. And that was really exciting to see. You can see it in the immediate window, but let me put some breakpoints in. I'm also going to skip the initialization function for now, just because I'm tired of putting in names. But okay, so game over is currently true. And the reason for that is it remembered it from the last run through. So let's actually just skip the player naming and set game over to false here. Okay, so game over is false. So because game over is false, not false equates to true, because not is basically negating the value of the Boolean, which means to flip its value. So not false equals true. So because not game over equates to true, we will execute this loop. So we'll step into it, print hello, game over becomes true. So now it's going to equate this again. Game over is true, so because this is now false, we no longer execute this loop. So we're done with that loop. Now we come down to the do loop. Now you'll notice that not game over is actually still false here. However, because we're telling it to do, it will execute everything in here at least one time. So it will print out hello, and now because this statement here is false, not game over is false, it will no longer process the loop and it'll move and be done. So a little crash course in Boolean logic there, a little bit of information about the difference between while and do while loops. The last loop, one of my personal favorites, is the for loop. And basically what the for loop lets you do is just determine a set number of times that a loop will execute. So for first of all, we need to declare an iterator. So we will dimension I as an integer, and we will then say for I equals 1 to 10. There are a lot of cool things you can do with the for loop. If you leave this next part blank, VBA will assume you want to count by 1. If you want to instead count by 2, you can use this step keyword to say step 2. And then the last part to finish off the loop is to tell it to move to the next I. So this will go 1, 3, 5. So there's the 1, now we step 2, so I should now be 3, 1, 3, 5, 7, 9. And now since I plus 2 and I was 9 is greater than 10, it doesn't execute anymore. If I get rid of that step 2, we'll just count to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One of the super fun, he said sarcastically, projects that we did in basic Introduction to Computer Science was the age-old, everyone's favorite song. It's a great way to learn for loops, but you start with 99 to 1. We're going to go in increments of -1, and stop me if you know what we're already going to do, but we're going to say I debug.print I and bottles of soda. Call it pop because it reads better on the wall. I bottles of pop. And we're going to use a special character here to move to the next line of code. Take one down, pass it around. And now we're going to say I minus 1. Bottles of pop on the wall. So, for those of you wondering what this will do, if it's not obvious, and it shows the power of the loop, because if I wanted to do this manually, I would have had to copy and paste this 99 times and update all of those numbers 99 times, and that would be really tedious. However, doing it this way, we're going to start, we're printing out I, which is 99, I, and then I minus 1, which will be 98. So we'll print out one line. Here it is. 99 bottles of pop on the wall, 99 bottles of pop, take one down, pass it around, 98 bottles of pop on the wall. And now we go again, and it counts down. It goes on and on and on and on and on until we get to 1 bottles. Now, if you want to be super neurotic, you can do some special logic in here. If I equals 1, then bottle or bottles. Just because grammar is important, everybody, okay? Can't be going around talking about 1 bottles of pop. 1 bottles doesn't make any sense. It just sounds silly. All right. And we need to do it in here as well, because if I minus 1, if I minus 1 equals 1, then put bottle, otherwise put bottles. Okay, now we've got a grammatically correct song. Grammar matters. Now the song is complete. You know, I don't spend a lot of my time in my professional life writing silly children's songs in code, so it does take me quite a while to get it right. 0 bottles, 1 bottle. There. It's grammatically correct, and everything is beautiful. Let's get back to tic-tac-toe, shall we? We know about looping. We've covered looping. We've covered it. We're sick and tired of looping. Let's get rid of these demo loops. We do, however, want to keep the while not game over. This is important. So we've spent a lot of the time today talking about loops, and that's okay, because loops are important. We talked a little bit about Boolean logic, also important. And we're basically just gonna write a shell here, so we're gonna turn handle here. Turn handler, which is gonna be a function to basically ask the user which cell they want to write their letter into. And then we want to, in the turn handler, we'll determine if there's a winner. So basically at the end of our loop here, we want to change whose turn it is. And we'll do that. We currently have an integer referring to which player is active, and we set it to 1. So there are a couple of ways we could do it. We could do it with a branching if statement. We'll say, you know, if current player equals 1, then current player equals 2, else. Equals B. And you know, that works. It's fine. One thing to note in VBA, single equals is equality as well as a setting. It all depends on context, so you don't have to worry about using double equals or triple equals as you do in some other languages, which is kind of nice at times. But this is, you know, it's like 5 lines of code, and we can do fun modular arithmetic. So instead of doing it that way, what I want to do is I want to say, okay, well, we'll take the current player, and we will set it equal to the current player, and we will then do some modular arithmetic. We'll basically divide by 2 and take the remainder, and we'll add 1 to it. And if you missed the Human Resource Machine video where we talked about modular arithmetic more in depth, I encourage you to go check that out. But just as a quick crash course, basically it is the modulo operator gives you the remainder of a division problem. So let's say you had 1 here. Basically what we're saying is take the current value of current player, which would be 1 because that's what we set in our init, and we want to do a division and take the remainder. So dividing by 2 because there are 2 players, and so 1 mod 2 is 1, and we want to add 1 to it to get the next number. Okay, so 1 mod 2 is 1 plus 1 to get 2. But then when we move on from there, we take 2. 2 mod 2 is 0 because 2 divided by 2 is 1, remainder 0. We add 1 to it to get our 1. And so now we're bouncing back and forth between 1 and 2, and we're only using 1 line of code, and we get to talk about modular arithmetic, which is one of my favorite things. So basically, from here, in the next video, we will start working on the turn handler. We will ask for user input, put the user symbol in whichever square they select. We'll have to have some input validation to make sure they're not putting it onto a square that's already been played, and we'll have to check for a winner, and that'll all be done in the next couple of videos. But for now, I will say thank you very much for watching. This has been a Software Engineer Plays. If you enjoyed the content, if you're finding it interesting, please like the video, subscribe to the channel, share it with a friend, turn on the notification bell. I hope you have a wonderful day. Go solve some problems, go play around writing code in Excel or anywhere else, and let me know how it goes in the comments down below. Alright, I'll talk to you later. Bye.